Everyone, and welcome. We're delighted to have you with us for today's fascinating program featuring Colin Reed and Dana Yerger from, did I say that correctly?
You did.
From the Woods Hole Oceanographic Institution. The ocean covers more than 70% of our planet, yet so much of it remains a mystery. It regulates our climate, supports an incredible diversity of life, and plays a vital role in the health of our world. But it also faces significant challenges, one of the most pressing being plastic pollution. This afternoon, WHOI scientists will take us on a deep dive into the science and chemistry of our oceans, exploring how plastics interact with marine environments, what happens to them once they enter the water, and the research being done to better understand and address this global issue. Whether you're passionate about marine life, interested in environmental science, or simply curious about the world beneath the waves, you're sure to come away with a greater appreciation of the complexity and importance of our ocean. Please join me in giving a warm welcome to Colin Reed.
And Dana here.
Dana after you, from the Woods Hole Oceanographic Institution.
Thank you very much, and thank you to Amy. The outreach that you do, the programming you do is awesome. It's the first, when I took this position 3 years ago, she was the first to call, and it was very cool. I will correct the information at the beginning. Dr. Chris Reddy, who is a marine microplastics specialist, as well as a oil specialist and an oil chemical signature specialist. He sends his apologies. He could not make it today because our school system is getting out today because of all the storms, and he had daycare issues and others. No, that's all right. But in his place, we have Dana Yerger, and Dana's amazing. He is part of our deep sea exploration team. So if I couldn't do plastics, I needed to do something fun and exciting. And having someone tell the story of our deep sea exploration, ranging from how we discovered the hydrothermal vents, to being part of the team that helped find the Titanic under the guise of something else, to how we do it today. Dana's been part of the team, and so that's why I invited him. So thank you for having us. As you'll see, our ocean, our planet, our future. It's a simple tagline, but one that's very, very important to what we do at Woods Hole Oceanographic Institution, and will be central to our presentation today. A little bit of an icebreaker beyond what we've already done. Step one, have any of you ever heard of the woman Mary Sears? Awesome, great. For those of you that haven't, have any of you heard of the story of the NASA scientists and mathematicians called Hidden Figures? Yeah. Well, imagine that this Mary Sears' story is the oceanographics version of NASA's story. It is, Dana and I, for the last, couple hours, because I thought our talk was at 9 this morning, so we got here at 9. It's not till 1. I have baby brain. My wife and I we just welcomed a new baby into our lives 7 weeks ago, so I'm still figuring it out. That's why we came early. We had a chance to talk about World War II stuff, and so many different stories that are becoming public about World War II. This one is one that I highly, highly, highly recommend. It's probably available downstairs. I hope it is. If not, we'll raise some hell. But this is Oceanography's Hidden Figures. There are women scientists who raised their hand to help the United States, who were told no thank you, and who time and time again fought to get the information out there. One of her bathymetric and ocean current maps finally made it to the ranks of an admiral whose one of his fleets completely got decimated. And he said, "Where did this map come from? Why did I not have this before?" The rest of the story unfolds there. It is an awesome story about World War II, and she and her team from Woods Hole helped, win an element of World War II. So read the book. I'm not going to go any further than that. Next icebreaker a little bit. This is one of our research vessels. We have three. We have two this size. This one is named the RV Neil Armstrong. The other one is called the Atlantis. The Atlantis is the mothership to the deep sea submersible called the Alvin. And she just currently got refitted, as did the Alvin, and she's out. But this one we accepted in 2015. I spent 12 years before working for Woods Hole Oceanographic, working in Washington, D.C. And we fought tooth and nail representing the oceanographic community, the research community. And at the time, we were fighting space exploration. Why do we spend tens and tens and tens of billions of dollars going to space when we don't know our own ocean, right? So fast forward, I come working at Washington, or excuse me, up to Woods Hole. And in England, they accepted delivery of a research vessel, and they opened up the naming process to the public. And they got some fun names. And the winning name was Bodie McBoatface. The US didn't want to duplicate that process, so they decided to name the two ships that were built by the US Navy but are operated and maintained by other institutions. One, the Neil Armstrong, the other one, Sally Ride. After 12 years of fighting the sea versus space fight, why the heck would we do that? Well, here's a trick question. Do you know why the space shuttles are named what they are? It's a lot ahead. Well, they're all named after seagoing vessels. So NASA did the first ode to planetary research. They named all of their vessels after our vessels. At the top right is the Atlantis, the original ship that Woods Hole Oceanographic Institution got in 1930. And we did some crazy science off of it. We didn't have OSHA back then, so we were smoking cigarettes and putting explosives off the side. Probably not condoned in today's world, right? But it was the start of oceanography. So what did we do? Well, we named a ship after Neil Armstrong and Sally Ride as an ode back to it. And what's very interesting is now there's a lot of continuity between the two fields of science. We are now getting approached by NASA to do research with them because we can gain decades of research and development of instrumentation and robotics and other things, because eventually they're going to want to put them up into space. And they do have a program right now trying to go up to space called, they're going up to a moon of Jupiter called Europa. They know from satellite imagery and other imagery that it has ice. They know that it has hydrothermal activity, something that we discovered at the bottom of the ocean. And they approached us and said, well, we know how to get up there, but we don't know ice. We don't know hydrothermal activity. We don't know deep sea creatures that are living off this no sunlight, deep sea chemosynthetic environment. Let's partner and join forces. So now it's okay. 12 years later, we're working hand in hand. So you're going to hear Dana and I talk about WHOI, WHOI, that's the Woods Hole Oceanographic Institution. As a dad joke in practicing, I don't mean WHOI. Our objective, for some of you that know us already, it's to reintroduce and re-engage. We are on Cape Cod. I think one of my first talks that I gave here, I invite everybody, as I will you, to come down and visit us. And the statement was, we love Woods Hole. The problem with Woods Hole is that it's in Woods Hole. It's not that far. We made it today. Come and visit us before it gets super busy in July and August. But if you come in June, you come in September, it's beautiful. We'll give you a behind the scenes tour. But we have down in Woods Hole a major scientific, engineering, and economic driver of Cape Cod right there in Woods Hole. We have a dozen institutions there studying the Earth. in many different forms and facets. Come down and see us. It's awesome. A lot of people forget or don't know that that bastion of science exists down there. So that's my objective, to tell you about that. It's also a little bit to rebuild and to build trust in science. Hate that I have to put that up there in today's world, but it's true. Because it's important. And specifically because when we think of earth science, we think of the traditional sense of astronomy, geology, and meteorology. But WHOI, Woods Hole Oceanographic Institution, we do oceanography, and that is the fourth arm of earth science. Within that, we have 1,000, about 1,100 employees that work at the Woods Hole Oceanographic Institution, and they support this oceanography: physical oceanography, chemistry, geology, biology, engineering, and everything in between. Those are what we call the silos or the departments, but it is all highly integrated. And especially with the engineering, because the engineering is spread across all of the departments. And it's the likes of Dana that will catch somebody at our local coffee shop, ask about the scientific endeavor that they were just on, ask pointed questions, and before you know it, they go down to the local coffee shop and paper napkin a robot idea out of nowhere. And then the special sauce that is WHOI is we can then take that to engineers to get CAD drawings, and we can manufacture a model almost immediately. Not immediately, but with some time. And that's the special sauce, is these big, beautiful brains that have a can-do attitude that make WHOI special. So come down and visit us. Come and, check out the special sauce. Sit at the coffee shop, because the problems of the world that are, in oceanography, it's happening right around you. And we have one Nobel laureate, but next door at the Marine Biological Laboratory, they have 4. And so that's, in the past. But what about today? You could be sitting right next to somebody that's doing some big thinking. It's enough about the WHOI intro. I'm now going to turn it to introducing Dana and deep sea exploration and robots. Not the plastics. Sorry if you came here for plastics. That's my bad. When you walk away from here, I want you to think of Woods Hole Oceanographic Institution as the center point here on Cape and in the world. We have many collaborations, so it's tough to say that. But what do? We explore and discover. Whether it's with our brains or with our eyes or with both, that is our job: explore and discover. You may know about us because we put human eyes, first robotic eyes, and then human eyes on the sunken Titanic. And Dana's going to talk a little bit about that in his thing. We are independent, like the library here. We are 100% nonprofit. How do we get funded? Each and every researcher like Dana writes a ton of grants. My salary is paid off of those. It's the overhead. I don't take my job lightly. That's why I'm here today. That's why I travel and try to tell the scientific and engineering story as best as I can, because we need more and more awareness about it. We do rely on philanthropy. The government, I will tell you, funds very safe research. And that's nothing new, but it's definitely something new in the last probably 3 decades. Because of congressional, what I saw when I was in DC, because of congressional pressure, they want experiments that will succeed with positive results. We know from the scientific process that even if something fails, that adds to the body of knowledge. It's okay to fail so long as you learn from it. So a lot of times the philanthropic monies that come in allow us to do the riskier research without ramifications from Congress. And it helps us prove a proof of concept to Congress to fund some of these established sciences. So we are independent. We don't answer to anybody except our board. We can flex wherever the money is. In our history, up until Cold War, we got our money from the Navy, a large portion. After Cold War, we went and we get our money from the National Science Foundation. Right now, to use a sailing term, we're stuck in the irons. We don't know which way it's going. We have indications it's going to Navy. We can do the same research. We just have to use different words. Instead of curiosity-driven humankind exploration, we're going to say we're going to defend our national assets. But it's this at the core of the same research. We have unparalleled expertise in the science, engineering, marine operations. I will add also education. We have a partnership with MIT for our PhD students. And with all that, extraordinary access to the sea with state-of-the-art vessels, vehicles, and facilities. Last image here, one of the last is the HOV Alvin, not named after Alvin and the Chipmunks, although it was created around the same time that the cartoon was. But one of our engineers who was in World War II felt we needed to use a lot of the tools and instruments from war for research. At the time, we did not have a submarine with windows. And so when I talk about the back of the paper napkin, back of envelope drawings, this man, the man who invented Alvin, his name is Alan Vine, he paper napkined the Alvin of what it could be. We have T-shirts with the actual like stick drawing almost. And here we got the cursor. He designed the contraption that would keep us safe. Is an 8-foot in diameter steel ball, hollow, steel sphere that can hold 3 people. How many times have you been in it? 6 times. It is hard to get in there. Not physically, just it is programmed so much because it's so successful. It's 62 years old, not this specific model. We've had many different models. We've had 2 spheres. The first one could get us to 4,500 meters. 3 spheres, thank you. First one, around 4,500. The new one is now 6,200, 6,500 meters, which gets us to about 99% of the sea floor. We just finished a refit of it today. So even though you see as big as it is, and it's about 30 feet long, this sphere, it's the only place where the humans are. We use robotics and we use vehicles to look for anomalies without eyes. He invents them. But to verify, we also use at WHOI and the ocean community, human eyes, and that's what he's going to talk about today. So please join us, help us meet the moment, come and visit. You can get my information from Amy. We'd love to have you. We'll give you a behind the scenes tour. We can organize something with the library, and so you can come in on a bus and not have to worry about parking. Anything I can do to entice you. But also our board chair gave us an incentive. This isn't one of those ones that he's already given us money and we're going to make a challenge out of it. He actually said, you guys, can you get 1,500 people in the next 2 months to sign up? And we're like, sure, we can try. And he's like, doesn't matter if they sign up for the newsletter, they donate $1, $5 or more. You can get 1,500 people, I'll give you $1 million right away. So please sign up. We're doing well. I asked for the thermometer to be where we are. I think we're, at the 2/3 mark. But just signing up, and you can see it inside the Oceanus. There's a QR code, there's a website. Please sign up and just get the information, because that is a win for us, period. Tell your friends, not necessarily about the competition, but like about oceanography and its importance, because that's a win for us. Because the more we have knowledge about it, the more we're going to have success stories. What you may have seen in the news of late, we were told to pull out one of our big infrastructure assets of the ocean called the Ocean Observation Initiative. We have huge buoys, huge systems out there monitoring the ocean 24/7, 365. We were told by the National Science Foundation to take it out because the administration didn't like it. And the scientific community rallied, and we have a pause. And it's all because not only did the scientific community rally, you all rallied. And, we're in weird times because traditionally speaking, under Republican administrations, we do extremely well as oceanography, and Democrats less so. And in today's world, like I said, We are agnostic. We do research. Our job is to understand the ocean. It doesn't matter who's funding or how. Our job is completely 100% unbiased, peer-reviewed research and engineering. Fair? All right, without further ado, here's Dana Yerger, and I will change the slides. Thank you for coming today. Any questions while I do this at the start? Floor is yours.
All right, thank you. Okay, well, thanks for coming today. I guess I should start with a bit of a disclaimer. I'm here today, I'm speaking for myself. Okay, so don't say, well, WHOI said this, because I speak for myself. Only the director speaks for the institution. The opinions expressed here are my own. So I thought I'd give you sort of my own personal view on how we explore the deep ocean and why do we explore it, and how is it that we built the machines that we do, and what kind of results that they get. Unlike I interact with a lot of colleagues from the more academic side of robotics, and they might pursue robotic interests based on maybe a commercial interest, or they might just be inspired, like, I want to make a robot that works like a spider. Okay. We build robots because we think that they are key to unlocking information about the ocean that we just can't get any other way. Or we can get it maybe less expensively, or we can make the ocean more accessible. That's why we do it. Everything we do, even if it's a very fundamental robotic development, it's still leading to knowledge of the ocean. And when I joined Woods Hole, I'm a engineer by training, a PhD from MIT in mechanical engineering, and I came to Woods Hole, and my boss's boss, who was the vice president for research, he said, I want to see, first of all, you're here to write peer-reviewed papers. Okay, that's your job. He said, and I want to see a paper in an engineering journal about robotics, and then I want to see a paper in an oceanographic journal to show that those robotic advancements are actually making a difference in helping understand the ocean. He said, so I want to see both of those kinds of papers from you. And in fact, that's been the model for people with jobs like mine. And ultimately, I was successful. Guess I don't need to labor on that. Colin already showed it. Deep sea robots, and these aren't all ours. These are actually a kind of collection. They come in different shapes and sizes for different purposes. WHOI's Remus is up in the upper right there. That's a variant of that, is what can swim in and out of a torpedo tube of a combatant submarine. And so the different robots for different purposes. Some of these are untethered, so we literally unplug them and we launch them over the side, and then we recover them when they're done their job. Others are connected by tethers, and of course those tethers are fantastic nowadays because they have fiber optic elements in them. So we have essentially infinite bandwidth connected to the bottom of the ocean, and we really exploit that. And then there's different variations. Some of the tethers are big, heavy cables that have a lot of strength. They can transmit a lot of power, literally tens of kilowatts of power, and then they have those optical fibers. In other cases, if you look at the red vehicle there, that's called Nereid under ice. It has a tether that's just a reinforced optical fiber. Literally, probably some people here like to fish. It resembles an 8-pound fishing leader. Okay, and we can spool out tens of kilometers of that and maintain our connectivity to the vehicle. It's like a spider laying out its silk. So anyway, I'll go through a bit more about this in detail as we go on. But the heart and soul of every one of these efforts is cooperation between scientists and engineers. people who want to solve problems about the ocean and people who want to bring those solutions to bear. Now, Colin did talk about the coffee shop conversation. That's absolutely true. There's a little more to it than that. Okay. The difference between an idea and actually being able to put one of these things over the side and have it accepted in a peer review kind of way, it's a big uphill push. Okay, it takes years and a lot of hard work and commitment. But that's our job. But so why do we need to explore the ocean? And I'm guessing for this audience, this might be kind of obvious, but the circulation of the ocean is obviously extremely important, and we need to understand it better. And robotics can play a big role in that, because robotics can enable sort of pervasive, inexpensive observations at scale, which is really what we need. And of course, things like sea level rise, these things are all very important. Certainly, the Ocean Observing Initiative that Colin mentioned taps into this. We'll talk about some other programs as well. One of the programs that, and this isn't part of my work, but I'm such a huge fan of it, is a program called Argo. We have thousands of these profiling floats. As a robot, they're pretty simple, okay, but they're also super effective. If you look at the diagram there on the upper right, you see that they basically follow a program trajectory that lasts a couple of weeks. They basically go to 1,000 meters, they drift along, and they're measuring everything that we know how to measure. Okay, then they go down deep to about 2,000 meters. They come back to the surface and they report the data. We have thousands of these. There's, I think, 4,000 of them out in the ocean now, and they drift. They can actively go up and down, but they can't propel themselves sideways. This has been a fantastically successful program. There are over 5,000 papers in the scientific bibliography using this data. And I like to say that a lot of the people who wrote those papers, they actually have no idea how these things actually work, but they don't need to. The data is there, it's curated, it's accessible. They can find the data they want, and they can write great papers about it. And that's really a measure of success. That's a very high bar, and the people who run this program have met that bar. 5,000 papers. That's the yield. And there are many variations of these. We have one of our scientists at Woods Hole. He takes these standard things. He actually has a smaller version of them, but he programs them, rather than doing this kind of stereotype thing that most of them do, to go up and down as fast as they can over the first couple hundred meters. And he's actually in, I think, the Air Force Reserve. He flies in a Hurricane Hunter plane, he and the students, and they toss these things out of the planes in front of a hurricane. Okay, so as the hurricane passes over, these things are going up and down, transmitting their data. And that data is gold, because it's showing the thermal structure of the ocean. And it's providing that in just the right place at just the right time to really understand what's going on as these hurricanes come. That is a kind of gold standard result for technology and science and people and imagination all working together. And you can find videos online. I should brought one, showed it. He's in his jump flight suit, and they're literally tossing the things out the back of the Hurricane Hunter airplane. It's like, gee, I wish I had that job. That sounds like that's really cool. So anyway, these robotic devices, and some of my colleagues in robotics, well, that's not really a robot. It's not like thinking and reasoning. I go like, yeah, 5,000 papers. How about that? Okay, that's what's important to us, that the technology serves science. Okay, one other really good reason to explore the ocean, and this is much more the kind of work that I've been doing. Some of you may know that the surface of our planet has kind of like the seams of a baseball. It's called the mid-ocean ridge. It's the biggest geological structure on Earth. It's 99 point something percent of it is underwater. Okay, and it's basically a volcanic chain, and to really shortcut what could be an entire talk of itself, these are the regions where the tectonic plates that make up the Earth's surface are being created. Okay, so they call that a spreading center. So on each side of those mountain ranges, there's a plate moving one side and a plate moving the other side. And at the tippy top is what my geological colleagues called zero age crust, brand new Mother Earth right there. Okay. So studying that and understanding the dynamics, which is really an endeavor from our lifetime. When I was in junior high, the idea of plate tectonics didn't exist. And we would tell our teacher, well, but Africa and South America really seem to fit together. Oh, no, that's just some kind of an illusion. Okay. Well, it turns out the junior high kids were right. Okay. So the plate tectonics and plate tectonics was verified by observations in the ocean using towed magnetometers. But now, people wanted a really close-up look at that and measuring it basically every way we knew how. And this has been a huge driver behind platforms like Alvin. Okay. There's some big books that we have in our libraries where they have all of the submersibles that have ever been built, and each one has a page, and there's usually a kind of crappy black and white picture, and then all the specs and maybe a sea story or something. And you look through there, almost all of them are in a museum or in a playground or in a junkyard. Okay. Why is Alvin still in business 60 some years later? Okay. Because it found a financial sustainable way to live. Okay. And that financially sustainable existence was to take scientists to places like the mid-ocean ridge where they can do their peer-reviewed science. Okay. One of the great quotes when my mentor, Bob Ballard, was early in his career, he was making the case for Alvin's depth capability to be extended to the 4,500 meters, which was to have the Navy build a titanium pressure sphere. That was the second sphere. And they had to go before the National Science Board. And the question that was posed to Ballard by this gentleman, Frank Press, who was a legendary, super smart, but cranky, powerful MIT professor. And Bob hadn't finished his PhD at that point. So he was Mr. Ballard. Mr. Ballard, can you point me to one piece of peer-reviewed literature that's come from observations from a submersible? And the answer was, no, but if we fund this, there will be. And the response from Frank Press, according to Ballard, was, well, there better be, or your titanium submarine is going to be titanium paper clips. So now, if I were to wheel the Alvin bibliography in here, all the papers, I would need like a couple of hand trucks. There are thousands and thousands of peer-reviewed papers that have come from observations and samples done with our submersibles. And again, that's the gold standard for us. So, so a lot of different tools. We use obviously Alvin. We use remotely operated vehicles like Jason, and we use autonomous vehicles. And then I lost my Abe picture there. Sorry. And I've worked on. So I did a lot of work on Jason. But I also did work on. Most of my career was spent with these autonomous vehicles that essentially do the mapping that provides the context for the close-up work that the remotely operated vehicles in the submersible. And I'll give you some. Oh, there's the Abe map. I just had to hit my button one more time. So these kinds of maps are sort of setting the table for the other vehicles that look closer and can do sampling and whatnot. In fact, I just read an article in the newspaper. I don't really know all the details, but some of our Chinese colleagues were in, I believe, the Indian Ocean, and they were diving in their submersible, and they didn't have any maps. They just went to the bottom of the ocean and started looking around, and they actually made a great discovery. They found a whale graveyard. Okay. And I thought, well, that's first of all, that's awesome. Secondly, it's pretty rare that you go to the bottom of the ocean in some randomly selected place and find something interesting. Normally, you have to have your scouts out ahead, okay, to find where the interesting things might be. My analogy is, imagine if Thomas Jefferson called Lewis and Clark in and he said, I want you to explore the American West. I said, okay, Mr. President. And I'm going to do a little time travel here. So he said, and here's what you're going to do. Every day, you're going to get an airplane and you're going to jump out with a parachute. But you have to do it at night in the dark. And then you have maybe 10 hours to walk around. You get a flashlight, a really good one. Okay. And you're going to look around, and then we're going to pick you up. Okay. And then tomorrow you can do that again. If you just have a submersible or a remotely operated vehicle, that's kind of what you're doing. Okay. You're literally parachuting into a place and you can't see very far. Now, when you get on the magic spot, now you have everything you need. But getting to that magic spot is not going to happen by parachuting in and looking around. Okay. So we use the autonomous vehicles to build these maps. And then our colleagues say, ooh, that's a fantastic spot there. We need to go there. And then we need to look at it in detail. So that's been the paradigm for many years. Back in 1977, when hydrothermal vents were first discovered, and these were the members of my laboratory from just before I joined. Okay, so I don't get any credit for this. I was still an undergrad when this happened. They used a relatively simple towed platform called the Angus, which had 35 millimeter cameras loaded with big reels of movie film, okay, and strobe lights powered by car batteries. And they would tow it along the bottom and take pictures, and they navigated it. So they knew exactly where it was the whole time. And then they would find interesting things that way, and then they could vector Alvin in. In fact, that's how the hydrothermal vents were discovered. They were first discovered in photographs and in temperature readings from a towed platform, a platform without any people in it. And then that information vectored the submarine. If people say Alvin discovered the hydrothermal vents, well, not really. Okay, because the guys operating the Angus told him exactly where to go in a navigation system. I don't have time to talk about that today. They always knew exactly where they were on the planet. Okay, and then you could bring another system in. But that paradigm of having one system that's good at covering lots of ground and being sort of the scout, and then the other platform that can come in and do the detailed work and take samples, we still use that paradigm all the time. This is some work that I participated in back about 10 years ago now. This is a volcano off the coast of New Zealand, and we went there and we mapped it with our Sentry autonomous vehicle, and we made this, I'm proud to say, beautiful map. And then at the same time, we had the remotely operated vehicle, Jason, and our scientific colleagues were thinking, well, with Jason, we can visit 1% of this volcano. Which 1% are we going to look at? Okay, well, maps like this was just what they needed. Okay, and then I have to show you my artwork there on the left. Those are all the track lines that I composed to do that survey, and I could talk forever about how that's actually what I really like to do and got pretty good at over the years. But so the idea that the autonomous vehicle is the scout, and then the remotely operated vehicle or the submersible then comes in and does the detailed close-up work in just the right place. That's a paradigm that we still do. The first time we made one of these maps with an autonomous vehicle was in 1999 on an expedition to the southern East Pacific Rise. Some of the scientists on board were very supportive and excited about what we were doing. Others were very skeptical and were upset that we were taking some of the ship time. They thought there were other things that would be better. At the end of the cruise, we had won them over completely. And I have to say, maps like this, we didn't even know we could do that when we went out on this trip, which was a fantastic result. But that's essentially, you see the map in the middle, that is a linear volcanic feature. There is literally a tectonic plate on one side of that crack, one plate, and on the other plate, the other side is the other plate. That is brand new Mother Earth right there down the middle. Okay. And so scientists, our scientific colleagues, many who were skeptical about autonomous vehicles. Well, they're so expensive and the engineers are going to take all the money and I don't know if it's really going to work. They saw that map and they said, I'm in. Okay, got to get me some of that. Okay, and some of our staunchest critics became our best allies. So, and that's part of the process. Now, unfortunately, we did finally lose Abe after 222 dives. It went down, didn't come back. A little bit of consolation. Abe got an obituary in the New York Times. So that was pretty good. And we got emails from people from all over the world, actually. We're going down the pub after kids in the UK. We're going down the pub and we're having Abe night, right? You know, but it had done its thing and it proved the point. And then Century was coming online, so which was its successor. So in that sense, we were okay. But okay, one more reason to go to the bottom of the ocean. Okay, we already talked about understanding the circulation of the ocean. We talked about the geologic processes that form our planet. How about the fact that the deep sea floor is a museum? Okay. There is a lot of human history on the bottom of the ocean. And the same deep submergence technology that we use for all those other purposes, we can use for that. And here you see the Ulubarun shipwreck. This is actually in relatively shallow water, so they use divers. But the amount of knowledge about the Bronze Age world that has come from that one wreck is extraordinary. And you can look that up. It's a fantastic thing. But of course, the shipwreck everybody wants to hear about is the Titanic. That's actually me down in the middle at the bottom where I had a lot more hair back, whatever it was, 40 some years ago. And again, we used the same paradigm that I told you before. We used a towed platform, which I think I can show you on the next slide, to scout the area and actually locate the wreck. And then the next year they came back with the Alvin submersible and explored it up close. So that paradigm of having a platform with no people in it that has lots of endurance, that can cover lots of ground to essentially act as the scout so that the submersibles can come in and do the detailed work is a fantastic paradigm. Now, I have to say that the technology for exploring these wrecks has just rocketed in the last couple of years. And, oh, I bet my video is not going to work unless this is anyway. This is actually a 3D reconstruction, not made by us. Okay, I can't take any credit for this. This outfit called Magellan. And this image was formed by taking 700,000 photographs from 2 different remotely operated vehicles that were very precisely navigated and controlled, and taking all of those images and fusing them together into this, what they call a digital twin. So it's essentially a 3D recreation. You can fly around in this model and you can explore the wreck of the Titanic actually in a way that the laws of physics do not allow you to do if you are actually there. So this is, and you can find out about this online. There's a National Geographic special about this work. And if I have any luck, we're going to be able to show you this video. But it's probably not going to work because we switched computers. Okay, well, if you search on Titanic digital twin on YouTube, you will find it. It is fantastic. So the idea that we're going to explore by going down and looking out a little window, no, that paradigm is ending. Okay, and this new paradigm of using our robotic vehicles to create an offline version of the real world, you know, with this digital twin, you can stand at a point, you can look down the whole length of the ship. Okay, the laws of physics do not let you do that. Okay, in reality, right? Because the water is cloudy, there's attenuation. You can't see that far. Okay, in this virtual world, you can. You can fly inside the ship to some extent to what anything that they were able to image from the outside. So it's a fantastic technology, and it's been Um, it's proliferating. Every underwater archaeology student in the world now knows how to use that technology at a smaller scale. Okay, they can go, they find a shipwreck or a sunken city or something on the bottom of the ocean. They fly around with their cameras in their scuba gear. They put down a couple fiducial references that they survey in. They photograph exhaustively the whole thing. They take all the pictures. They go back to their lab and they create that kind of a 3D rendering. And those things are analytically valid. You know, you can put a meter stick on the image and it's right. Okay. And every underwater archaeology student in the world now knows how to use those tools. It's a fantastic revolution. It used to be a few people with PhDs in computer science could do it. Now everybody can do it. It's a fantastic thing. Okay. One more reason to explore the ocean. Well, remember we talked a lot about getting to the seafloor, and most of my career was spent getting to the seafloor. It turns out there's a lot of interesting ocean between the surface and the seafloor. In particular, there's an area that we call the twilight zone, which is down to about 1,000 meters. That's kind of the extent to which the life there is directly influenced by sunlight. Deeper than 1,000 meters, there's a little bit, there's a few photons, but not many from the sun. So we call it the twilight zone because most of the time it's nearly dark, but it's not dark. Of course, during the day, the top 200 meters or so is brightly lit. That enables green plants to grow through photosynthesis. Okay, that's a lot of what we call, scientists call the primary production. That's where the energy of the sun and the chemistry of the earth produce basically nutrition for everything else. Okay, but of course at night, there is no more primary production, but there's something very interesting that happens, which is many of the animals that live down deep migrate up into those richer near surface waters because there's a lot to eat there. Why aren't they during the day? Because if they come up during the day, they're going to be somebody else's lunch. Okay, so they stay down deep during the day, and then at night they rise up. This is called diel vertical migration. It's the biggest migration on the planet. Nothing comes close. You see, planet Earth to the wildebeest running across the fantastic, right? It's a tiny fraction of what is going on all the time. This is going on all the time. Somewhere the sun is rising and somewhere the sun is setting. And so where the sun is setting, the animals are rising, and where the sun is rising, the animals are descending. It's happening all the time. And when they do that, they're actually carrying nutrients and therefore carbon from the near surface waters down to the deep ocean. And that's probably an important element of what we call carbon sequestration. Okay, we know that we have too much CO2 in the atmosphere. We know the ocean has a capacity to absorb a lot of that. Where does it go? How much of that is actually going to stay in the ocean and end up sort of inaccessible in deep water? And how much of it is going to come right back out again? That's one of the reasons why we need to understand these processes. So it's super important. It's also super interesting. These animals are beautiful. Most of them are not known to regular people. The most numerous vertebrate on Earth is these little midwater fish. Okay, there are tens of thousands of those little fish in the ocean for every human on Earth. Okay, but we don't see them, we don't eat them, and they are forming the basis of a food chain for a lot of the fish we do like to eat. Okay, so I'm just going to show you a little bit. Well, the robot that we built is called the Mesobot for doing this midwater exploration, and this video probably is going to work because I embedded it. I hope it's going to work. And it's not going to work either. This is why I hate to switch computers. Sorry. It's a really good video. I'm disappointed. Actually, want to do a quick change? Do we have time? No, we don't. Damn.
We can do it at the end.
Okay, how about that at the end? I'll show you both of the videos, anybody who wants to stay. Okay. Okay, so in closing, you know, I, you know, we talk a lot about the technology, we talk a lot about the science. You know, just like, I don't know what all your professions are or were, but you know, in the end, it almost always comes down to people. It doesn't matter what you're doing in life, okay? And our world is no different, okay? So one of the things I always emphasize that, you know, we don't just push a button and launch a robot and it explores the ocean. Everything we do, our robots are an extension of us, whether it's one where a human is actually driving it, okay, or whether we're programming it and then monitoring it and then analyzing the data when we get it back. It's all an extension of the people. If you watch the people in the control room of a Mars rover, that machine is an extension of those people, I think. Okay. And it's distant, it's not nearly as well connected as we would like, but still it's our, as my friend Larry Maiden said, it's an avatar of us. And I think that's a really cool thing, that no matter how much the technology appears to dominate, all of that ends up coming back to be a projection of the people who created that technology and the people who operate it. So, in any case, and then of course, I always have to acknowledge that, you know, we got here because we have good sponsors for this kind of work. Some of them very conventional, National Science Foundation, some of them very unconventional, Audacious Foundation. You know, it's very important to acknowledge that. So I guess maybe we have a minute or two, and then I'll set my laptop up and we can look at those videos for anybody who wants to stay a few minutes longer. So, thank you.